Hello everyone and welcome back to this final WeeW episode for the tutorial related to the communication between Python and the microcontroller. So we have been seeing how to communicate. We have been building the program from the ground to read the data from our microcontroller. Within this episode, we are going to focus on another perspective, which is the time analysis. And this time we are going to read and review how our program is interacting with the microcontroller, what is the efficiency that we do have, and understand some of the problem of our program, then have some conclusion. So if you would like to know a little bit more about the time analysis of our program, just follow this episode. This is the last part of the tutorial, and we are going to focus this time on the time analysis of the communication between the microcontroller and the Python program. At the end of this tutorial, we will see a review of what we can improve and also some recommendation. So this tutorial is at the end, and this is the last part. So this is the part where we are going not to program, but we are going to take a look more on understanding the timing and the timelines of how the program should be working. And as usual, the analysis that we are going to make this time is available on GitHub, including the program. Also, we are going to use Excel for this time, as we are going to use it for making a very simple analysis. Then we are taking a look on the language C within Kale, so we will change a little bit the code within our microcontroller to have a little bit of information on the time parameters. After that, we are going to take a final look on our program on Python using VS Code. And finally, I will explain everything, and you should be able to understand even if you didn't follow up this tutorial. But that would be great if you have the background so you can enrich really your experience of this tutorial. Okay, for the hardware, as usual, we are going to use the STM32F1 based board, which is the aka Blue Pill, and also the FTTI to allow the communication between the STM32F1 and the PC and Python. And finally, some variable resistance, so we can play a little bit with the value that will be going from the microcontroller to the Python. Okay, so from the tutorial perspective, first of all, we are going to take a look on theoretical UART data output. So we will see how much we should have been having data. And then after that, we are going to make an estimate for the data flow and see through the microcontroller having a short time analysis. Then we are going to check the comparison between theoretical and experimental. And after that, we are going to take a final review on the Python architecture. Then at the end, a summary with the opportunities and conclusion. Okay, let's don't spend further time and go to theoretical UART data output and see how long it takes to get all the information. As we have been discussing in the previous tutorials, we have agreed that the message that we are going to send is composed in this way. So at the beginning, so each message or each fragment of the message will have the pound in front of it. We do have the first one, which is the key. And after that, we are going to send a bunch of messages, each one of them separated by pound. And after that, we are going to send the validation number. And at the end, we will have the pound and the /n or a new line that will be indicate to Python that the message has ended. Okay, so the key is usually one character, so the key plus pound will be equal to, and we are going to count at our maximum case. So from the ADC perspective, it's a 12 bits, so which means that we will have a maximum length of this one to 4096, which is 4 digits, including the pound, which means we will have 5. And in our example, we have been using 5 inputs in our program. 4 inputs. So we will have 4 inputs having 5 digits. Then we will have the check. The check will be count the number of digits that we are going to send by word. So we will have 4 words and each one of them a maximum of 4. So it will be 16, 16 the maximum number. So from digit perspective, it will be 2 plus the pound, it will be equal to 3. Then finally, we will have the pound and /n, which is 2-digit. So in total, our program will have 27 bytes that it will be going to send. So this is the total of a maximum message that we are going to send. Then, if we go from baud rate perspective, and the baud rate is bits per second, and if we go here, that's the baud rate we have been using, which is 115,200. Let's type it here, and I count it here just by dividing by 8. So every second, it will be sending 14,400 bytes, and which means we will be sending 14.4 bytes every millisecond. But as our message is 27 bytes, we will need around 1.88. It's almost 2 milliseconds to send a message, which means, on the other hand, that the maximum number of word that we are able, or the message that we are able to send within 1 second, is 533. Okay, this is theory, but also this is only sending the message, is not including other computation happening within the microcontroller, which what we are going to see in the next part. To analyze the program or the time inside the program, what we are going to do is to put some timestamp variable and read them. And so this is the start time. This is when our process will start. This is how long it takes to read all the ADC data, and finally the complete time. So let me go here, zoom a little bit so we can see together. So everyone, I think, if you follow that, is familiar with the process. But in general, we do have here a core program running, and so please ignore this one at the beginning. So we are going to take here, so we are going to read the data. This is reading the data, and after that, sending the data. And what we are going to do is, first of all, so we are going to read the final data, but let me go to this one at the end. So we are going to use our timer library to, first of all, initialize a timer, and this timer will be 50 milliseconds, which is far way more than how long the process will take. After that, what we are going to take is take the time, or the start time, which will be coming immediately after this one. So we know exactly how much offset between these two events. Then there is another one, which is ADC read time. So we will check how long it takes to read the data from the ADCs. And after that, the program will keep running, and then when it will coming back, we will read the time just before we reinitialize the timer again. So this is our program, and here, let's see it here, this is our microcontroller already there. So let me save, build, and load the program. Okay, so to visualize and to see how long it takes, we need to go then on the debug mode. So let me go for the debug mode here and run my program. I already put this variable to be seen. So what to make it visualize, or to visualize the value, you just have to select this variable, and after that you go to add the variable, and here I'm adding it to H1. And the value will be initially shown in hexadecimal, but if you'd like to see the number, you just play with this one. Here we would like to see it not in hexadecimal, but in normal decimal way. So at the same time, so let's initialize. Okay, let me bring back. So let's connect. So, okay, we are successful. And let's just to have a visualization add this value here. So I will put all the channels, so we are sure to visualize everything, and we would like to have is the maximum number. So let's start here. We do have everything. So as you can see, so it's a different one because we do have different variable resistance, but we are at the maximum of each value here. So we are almost at the maximum. And so this is quite good. So let's show you here. So if I play a little bit, so this is really the maximum. If I just change like this, same for this one, same for this, and same for this one. Okay, so all our values are within the maximum possible. And let's go back and take a look on the value. So we do have here start time. So it takes 2 microseconds, because here I'm reading in microsecond. It takes 2 microseconds to get from the timer to reading this data. And after that, the ADC reads the data, all the data, and put the values after 8 microseconds. Quite fast. But the whole process, which is mainly sending the data, takes 2393 microseconds, which is 2.3 milliseconds. So this is the time that we do have. And using this one, we can jump to our code, to our Excel again, free this one and hide it. And so the actual process takes, so as we checked here, 2.339. So this is the process that takes, so 2.339. This is including customizing the data and everything. So it's 80%. So we do have 20% of processing and 80% sending the data. That's quite crazy from process perspective. So we should expect here the message rate that we do have is the number of theoretical message multiplied by this. Okay, so we will have around 427 message per second. Okay, so that's in theory as of now. So the next step is to make a real sample of the data and to see if this is exactly what we do have or not. So in the previous part, we have estimated how long it should take or how many messages we will receive by 1 second. So now we are going experimental and start doing this. And to get that, we are going to connect again. And what we are going to do, so let's add a visualization just in case, and we are going to record the data and to see how many record we have per second. So we have all the channels, we put save, and we start the saving here immediately. So the data is saved, and what we can do is have a sample of data for 10 seconds or 20 seconds would be great. So you would see here appearing quickly the file that will be related to saving the data. Okay, so we do have now more than 20 seconds. We are good. So let's stop here and stop. So we do have the file here. And I added one library. So let's go here. One library that will help visualization, which is, I guess, OpenView. And this is my file. And if I go till the end, so we start for almost 0 second, and we do have up to 22 seconds. Perfect. And you can see each time we have a word of 4 characters. So let's save everything, Control A, Control C, and go back to our Excel file where I have a data sample 1 here. So I will just copy like this. And what I'm going to do, so this is pure Excel formulation. So here I'll be rounding up every number to get only the integer part or the decimal part. So we will have up to 22. So this is maximizing here, taking the maximum of this column. And after that, I'll be counting. I think this one is quite wrong. Probably, yeah, I do have more than I need. So let me go here, delete everything. Perfect. And just in case, we are not going to take from 22. And this is the only number we are going to take. And we are going to count based on this average. So you can see at the beginning it starts well, and then the performance goes on down. And that's very important. So this is quite a good way to see how many data you get per second. So generally speaking, here we are, so if we take the minimum, so this is the number, so in the second number 0, we had 429. And if we go back here, it's almost perfect. So we were quite good. And after that, the performance goes down. And this is because there's some problem with the biserial, which is sometimes create not reading the data properly. So if we go back to our code here, not actually to Visual Studio, and we run the code again, you will see that it will generate some issue happening when Python is getting the data, which is really interesting to see and to know. Okay, and that's why we put a lot of filtering when we build the data reception, so we don't get any trash data. Okay, so now that we do have and we know how much it takes here for receive, we can go and compare. So let's go here and take, so this is the experiment, and if we go take the analysis, which is this one, no, actually it's the opposite. We go here and we got this one here, and this one will be the ratio. Okay, divided. So we do get 73% of the data that we should receive. It's not really bad, but you can see and understand that there is a gap. And this is very important when you set up your program, to be sure that you have a requirement of a certain number of data and the maximum number that Python can handle. Okay, so now that we have made a quite a review of the time analysis, we can take a look on our Python program. So this is the whole Python code we have been working on together through the whole 14 previous tutorials. So there's few remarks and things that would be done better that I would like to share with you, so all of you can learn from this as far as I have learned myself. So first of all, for example, when I started here in the user interface, a good program would have a good description for the method that we do have here, so it's much better to understand what's going on, and from maintainability perspective, and also when we share this program, people will not hate you. Another thing is, this is just from a program writing perspective, but as you can see also here, I'm reading the data, so my data is working and everything, but one of the problem is my terminal is throwing this error, and this is something not clean. From programming perspective, I should have worked myself a little bit, and from the exception here, I shouldn't just print that. So what is good is this exception is managing well the errors and the issues, so it doesn't make any trash within my data, but it's better to be sure that we manage much better the errors. So this is one of the weaknesses of this program. Which drive me actually to the next point, which is here there's maybe a further time analysis that can be done, and as we have seen in the previous section of this video, that we do not have the best efficiency for reading the data. Maybe some review for the serial and a deep dive on this library would give us a better efficiency. Then what we do have also is the modularity of this program. So I divided this program on 3 big files, and in the master data or the data master class, I have put in a lot of methods, which I think made this class very heavy. So one of my advice is, so here the data master should just managing the data, just managing the flow of the data, and it can be also coupled with the serial. And after that, when we start playing with the data, transforming the data, I should have created another class which will divide this class and will not have a big class and will be much easier to maintain. Last and final point is to be sure that the program is working properly, maybe I should have created some test.py program to test if everything is going well or not. So that was all the review of this program, kind of a review or self-critiques of my own code. If you do have any comment or you would like to give me further idea about how this program has been, like some improvement, I'll be very happy to read what you are telling me in the comment section. So now let's go to the final conclusion and the opportunities that we do have. Let's have a final look on the opportunities and conclusion that we can get from all what we have done within the 14 our 13 previous videos. So first of all, the reading of the data is quite important, and maybe here, as we said, working further on the Python to achieve the 100% data transmission, which will make the program much more efficient. Also, maybe there is a use of other language, because when I use the C or the C++ to get the data, I have 100% success on receiving it to get UART. But the complications, it's far way more difficult to put it using C. Then from the Python perspective, core things is, first of all, enhance the program modularity. So use as much as possible, divide your program, have a good modules and specific functions. That will help you a lot to have a good program. And then finally, keep clear comment for later guidance, so that will help you, because in 1 year, 2 years, when you review your program and you're trying to debug, it's really difficult to understand where things are going. And certainly a person like me who give a really not good names to the functions, that will help me a lot to understand what the program is doing. Then finally, this is quite a difficult one, but if you are able to develop a test.py to check your program vulnerabilities and bugs, that would be great. So this is the last slide of the whole tutorial. I have really appreciate working with you guys and shared with you the whole tutorial. And if you followed up to here, up to this last one, I really would like to thank you a lot, and truly believe that you'll be a great person and achieve whatever you want to do as you follow this, and also as you had the courage to finish the whole tutorial. Thank you a lot, and see you for next episodes. Thank you.